Welcome, class, to Lesson 5-3, Day 2. Today, strong mathematicians can solve problems involving different units of time. So yesterday we talked about time and time relationships. Today we're talking about elapsed time and how time moves and how we can solve problems that go with that. So you just show out your pencil and your notebook, write down today's date, the name of the lesson, and let's get started. So once again, we talk about base units of time. These base ratios, or relationships as I like to call them. We have this figure filled out from yesterday, so we don't have to fill it out again. Or we can quickly buzz through this, but I think we're in good shape. So since we're talking about elapsed time today, I'm just going to fill out these two, which might be important. 1 minute equals 60 seconds, and there are 60 minutes in an hour, and there are 24 hours in a day. So we'll stop right there. Oh, sure, we'll finish this one. 7 days in a week, just as a good review. So with that, we'll move on with today's problems. If you don't have those three, you can write those down. If not, pause the video, try to figure out the other ones, and we'll keep moving. Or watch yesterday's video to fill them out. So how to tell time? The shorthand points to the hour. So notice there are two hands on the clock. This right here refers to the shorthand, which means it's pointing at the 2. So it would be 2 o'clock. The longhand points to the number of minutes. So here's the longer of the two hands. This would be the number of minutes. They are separated. Numbers are separated in groups of 5. So notice between this 12 and this 1, there are 1, 2, 3, 4, 5 minutes in the clock. So if we kind of count, we got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, which shows us that 1 hour equals 60 minutes. So most of you don't recognize these clocks now because everything has gone digital, but we still see some of these there, so we need to be able to understand what they mean and how to tell time from it. So with that, let's get into some of our problems. You can pause that video down to help you out with the longhand and the shorthand and the separations of 5 so you kind of get how we count through this. So some examples. How many hours have passed since 12 on each of the clock? So how many hours, how many minutes since 12 o'clock? So here we've got, it is the shorthand's right here. So here's our shorthand. Shorthand's pointing to 3, so this would be 3 o'clock. So on a digital clock, it would look like this, 3 o'clock. So the question is, how many hours have passed since 12 o'clock? Well, that would be, our first answer would be 3 hours. The next one is, how many minutes? Well, we know that in each hour, there are 60 minutes, so we have to do 60 times 3, which would give us 180 minutes have passed since 12 o'clock. And we're going to do the same thing on this problem. Notice that there's the long hands on 12. This one's at 8. So that means it's, right now, you'd see this on a digital clock. You would look at this, 8 o'clock. So now the question is, how many hours have passed? Well, 1, 2, 3, 4, 5, 6, 7. It would be 8 hours have passed. And then how many minutes? Well, that same relationship. We know that 1 hour equals 60 minutes. And I have 8 hours, so I have 8 groups of 60. So 60 times 8 would give us 480 minutes. So you can pause the video now, write down this information to help you out. Maybe even draw a little clock. You don't have to draw every single part, but get an idea of the shorthand and big hand, and then how to find hours and the relationship between hours and minutes. So now, how many hours and how many minutes does the clock show? Write the time that the clock shows. So we kind of talked about that before. We did that example with 3 o'clock and 8 o'clock, but it's not always where the numbers line up exactly on the hour. So sometimes it doesn't look that. So first off, we look at our hour hand. Right now, it's kind of between 2 and 3, which means if the hour hand's between those two, it always goes back to the one before it, because it didn't get to 3 yet, so it's past 2, but it's not to 3, so it would be 2. The next part, we got to count our minutes. We know that we count these in 5s. So this would be, so from here to here would be 5, 10, 15, 20. So this time on the clock, I'm going to erase all my marks right now, that we can see it in its natural form, would be 220. That's what that time would be if it was on the clock. The next one, so we look at our hour hand. We notice the hour hand's between the 5 and the 6, which means it's not to the 6 yet, so we got to put a 5 there. And now you figure out how many minutes do we have? Well, we know that this is 5, 10, 15, 20, 25, 30, 35. So this would be 5:35. And you pause the video right now, draw the clock, draw the time, so that way you can connect those two, what it looks like on the clock face, to what time it would look like if it was digital. So I guess I wrote the time clock, but it says, I should probably answer the first question now that I read this. How many hours and how many minutes does the clock show? Well, this one shows 5 hours, 35 minutes. This one over here shows 2 hours. And then this one shows 20 minutes. So that's how you break apart the parts, and then together we'd see them as 2:20 on the clock or 5:35 on the clock. The digital clock that we now see most around us. So how many hours have passed between the times shown on the two clocks? Well, we're going to use our information from the last time. We know this was 2:20, and this was 5:35. So they want to know how much time has passed between 2:20 and 5:35. One way we can solve this, which works out nicely, if this is the case, like this one does, we can actually subtract the time between those two. So if we subtract 2:20, since our hours are smaller and our minutes are smaller, it's really easy to do it this way as a subtraction problem. 35 minus 20 was 15. 5 minus 2 would be 3. So they want to know how much time has passed. It would be 3 hours and 15 minutes between the two times. Now notice this usually works out well if we have a bigger number in the hours and a bigger number in the minutes than what we're subtracting from. If not, we got to kind of give out the relationship. It looks a little confusing. There are other ways I would try to solve a problem that looks like that. Here's another problem as well. Said Hannah practice starts at 9:45 a.m. and ends at 12:35 p.m. How long is Hannah's practice? So this would be one where we're trying to set this up as a subtraction problem like I did last time. Well, I have 12:35 minus 9:45. Well, the problem I run into is right here, I have more minutes on the bottom than I do on the top. So that would lead me to have a problem. There's another way of solving it. I'll show you that quickly, but I like to use a timeline, because I think timelines really kind of help me. Here's 9:45 a.m. and the end time is 12:35 p.m. All right, so what I'm going to do is I'm going to add 15 minutes plus 15 minutes. Why? Because if I add 15 minutes, I'm now at 10 o'clock. All right, so now I'm going to go to 12 o'clock. So then this would be 11, 12. This would be 12 o'clock. Which would be then, this would be plus 1 hour. This would be plus another hour. And now I'm going to go from here to here. I'm going to add, all I'm going to do is add 35 minutes. The nice thing now is it's going to add my hours together. So I have right here 2 hours. So 1 plus 1 would be 2 hours. And then I add these minutes with these minutes, which would be 15 plus 35 would give me 50 minutes. So 2 hours and 50 minutes is the distance between 9:45 a.m. to 12:35 p.m. So to see that right now, this would work out in this situation. If I want to show you how to subtract it, here's the really big thing that you have to remember. This is a relationship. This really stands for hours, and this stands for minutes. So if I'm going to actually subtract here, I need to trade. I don't have enough minutes to subtract, so I need more minutes. So I'm going to trade in an hour, so my 12 would become an 11. I traded in 1 hour. Well, 1 hour equals how many minutes? That relationship would be 60. So now I'm going to add 60 minutes to my 35 to get 95. Now I can subtract. I would get 2 here. I would get 5 and a 0, which equals my 2 hours and 50 minutes. The biggest thing people run into is that when they subtract, using the subtraction method, is that this relationship, they forget that this is a relationship, and they will cross off 11 and put 135 and get 2 hours and 90 minutes, which would not be the case. So that's why I like this method, using the timeline and then jumping by minutes and hours to make it easy. But people can also use the subtraction method. That works as well, as long as you understand that relationship when you have to ungroup and change an hour for more minutes. So you can pause the video right now, write down both methods, what method works best for you. So try the timeline method, try the subtraction method, try them both, till you develop which one and understand them and how they work together. Right now you can draw a big line on your piece of paper, right? Box 3, now your turn. And answer the following questions. How many hours have passed since 12 on each clock? How many minutes? So write those two down for those two clocks. The next problem, how many hours and minutes does the clock show? Write the time that the clock shows as we learn about time and how to read the clocks. And that same one from that, use that same information right now and tell me how many hours and how many minutes have passed between the times shown on the two clocks. You could use our strategy of using the timeline, or you can also use a subtraction. Use what method works best for you. If you're not sure, go back and watch that part of the video again to help understand the two methods that I used. And a problem for you, the school store is open for 1 hour and 45 minutes in the afternoon. The store closes at 2:55 p.m. What time does the school store open? So you can pause the video, try to solve that one right now, either using the timeline, counting backwards, or you can use subtraction, try different methods and see what answer you get. As always, if you have any questions, comments, or concerns, feel free to write them down or share them out. If you have any strategies that you use, make sure you include them in box 4. And as always, thanks again for another great lesson.